Hey guys, today we are talking about lesson 2.4 and our descriptive statistics. We're talking about measures of variation. So our first measure of variation is the range. And the range is just the difference between the maximum and the minimum data entries in the set. So a formula for it, pretty easy. That difference means subtraction. So range is max minus min. So let's look at an example of that. Corporation hired 10 graduates. The starting salaries for each graduate are shown. Find the range of the starting salaries. Ordering your data from least to greatest can help you, or ordering the data can help you find that least and greatest. So pause the video here, find that least and that greatest, and max and min, and find our range. Okay, hopefully you got a chance to try the problem. So here you can see I ordered my data. I found the minimum number, the maximum number. I plugged it in to max minus min, and I got a range of 10. Our next type of variation is called deviation. So that's the difference between the data entry x and the mean of the data set. So this is just any data entry, how far away it is from the mean. So we have our two different types of data sets. We have population and sample. So we have those two different deviations. We have x minus mu and x minus x bar. So deviation doesn't tell us very much since it just looks at that one data point. So deviation is just a stepping stone to standard deviation. Standard deviation is the average distance a data entry is from the mean. So it's taking into account the deviation for each data entry and finding that average. So they have somewhat complicated formulas. So for our population data set, we use this sigma as the symbol. And that is the square root of the summation of each x value minus mu squared over that population set, like the population size. Our sample data set, when we find that standard deviation, we just use S, and that is the square root of the sum of each x value minus x bar squared over 1 minus the sample size. So that is a bit of a complicated formula, so we use technology to help us. So in this example, we have office rental rates for Miami's Central Business District, and we're going to use a calculator to find the mean and the standard deviation. So this has instructions for a TI-84. We're going to enter our data into list 1 using stat 1. So when you hit stat, it's going to say edit up top, and then 1 under edits, edit again. So you want to click on that, and that's going to bring up L1, L2, L3. And we want to list all of this data. All of it goes into list 1. So all of it goes into that same column. You hit enter between each data entry. And if you need to clear L1, you want to highlight L1, hit clear, and then enter. So once you've entered in all of that data, all into the same column, L1, you're going to run what we call one var statistics. And that's just short for variation. So using stat again, you're going to arrow over to calc and hit 1. Make sure that list 1 is L1 and hit enter until you have your answer. So you've entered in all of this data into list 1. You're going to run that one var, and it will bring up lots of information. It'll tell you the x bar, it'll tell you the standard deviation, the sample size, the max, the min, Q1, Q3, it'll tell you the median. It gives you all kinds of information. So if you run this data through L1 through 1vars, you're going to find a sample size, not a sample size, sorry, a sample mean, an X bar of 33.73, and you're going to find a standard deviation, that SX, of 5.09. Okay, so we have a number for that standard deviation, but what really does it mean? What do different sizes of standard deviation mean? So the more entries are spread out, the greater the standard deviation. Okay, because remember that standard deviation is the average distance that a point is from the mean. So the larger the average distance, the more spread out those points are going to be, whereas the smaller the average distance, the closer in everything's going to be. So if you look here at this middle example, you see all of the data all in this one place. So if everything's the same number, then the average distance for everything is, then the distance for everything is 0. And so that average is 0. And if you look at our next example in the middle, everything's pretty close together, but there's a little bit of range, a little bit of variation. So we have a standard deviation of about 1.2. And in our last example, our data is much more spread out. And so you can see a growing standard deviation. We hopped up to 3 there. So the larger your standard deviation, the more spread out your data entries are. So let's do a check for understanding. If you have a TI-84 calculator that you can use, this is a great time to practice that L1, putting it to 1vars. So using this data set, go ahead and clear your list 1. So you want to highlight L1, hit clear, and then hit enter. And then go ahead and enter in this new data set. And you want to find your X bar sample mean. You want to find your standard deviation, the median, and you want to find the range of the data set. So go ahead, pause the video here, find that sample mean, standard deviation, median, and range, and come back for the answers. Okay, hopefully you got a chance to try the problem. If we look at our answers, it should have given us, and we wanted to take it out to the hundredths place, 2 decimal places. Our X bar should be 12.6. Our standard deviation should be 2.60. Our median should be 12. And our range, max minus min, should be 10. Okay, awesome. We're going to keep on with that same data set from in your packet. And we're going to go to a place called Stapplet.com. Choose one quantitative variable, and you're going to enter in the data values. It tells you on the website that you can either use commas or you can use just spaces to enter in the data values. But go ahead, go to Stapplet.com, choose one quantitative variable, and enter in those data values. And make sure it's on dot plot, and you're going to sketch that graph below here. So take a minute to go do that and then come back to the video. Okay, hopefully you got a chance to go to Stapplet and create that dot plot. So this is number of shoes, and got it copied down on your paper. So we're going to take this graph and we're going to answer some questions about it. So if you look right below our graph, number 3 wants us to label any gaps, outliers, or clusters. So let's go ahead and do that. Remember, gaps are anywhere on the horizontal axis that does not have a data entry. So this right here is definitely a gap, but this spot right here is also a gap because there's no data point over 13. Okay, let's see if we have any outliers. We do. Over here, this 20 is definitely an outlier. It's far away from that data set. And then it wants us to label our clusters. This right here would be a cluster. This right here, though much smaller, it's also a cluster of data. And there we go, we have our different features of a graph labeled. Number 4 wants us to say if it's symmetric, uniform, skewed left, or skewed right. So if you look at your graph up top, you'll see that most of that data is pushed to the left side, and that means it's going to be skewed right. Because remember, we think of the opposite when we think skewed. Number 5, what would you use to measure the central tendencies, mean or median? If you look back in our lesson 2.3, you'll remember that we said if our data is symmetric or if it's uniform, we use our mean as our central tendency. But if our data is skewed or if it has outliers, we use our median. So our data is both skewed and it has an outlier, so we're going to use that median. So because it is skewed and has an outlier. Awesome. And the last question, is it unimodal or bimodal? So this graph really just has that one peak at 11, that like 10 to 12 area. So this would be unimodal. And that is lesson 2.4, types of variation.